Heyo. So, several thousand years ago, this crazy man named Pythagoras came up with a theorem, which is sort of like a formula or a recipe, in order to determine the length of any missing part of a right triangle. He saw a very special relationship between the parts. So, just a little review first. If you see this little symbol in the corner of a triangle, it means it has a right angle. Any triangle with a right angle is called a right triangle. If you don't see this symbol in the corner, then you can only assume it's a right triangle, and you know what happens when you assume. Here we're going to take a look at the parts of a right triangle. The side across from the right angle is called that's right, hypotenuse. The red line right here that I'm showing you is highlighting the hypotenuse. And the hypotenuse is always the longest side of the right triangle, and it's commonly labeled C. See, I've scribbled all over the triangle to show you that if you look in the direction of the scribble from the right angle, you'll always see the hypotenuse. Now, the other two sides are called, that's right, legs. Usually one is labeled A and the other B. Which one is A and which one is B? That's right. The correct answer is it doesn't matter. Now maybe this looks familiar to you. If we see the squares of 4 and the square of 3, which are 16 and 9, they add up to the square 25. You find the square root of 25, which is 5, and you found the missing leg. It's a little complicated to look at it like this, so let's just make sure we understand. First, what is the hypotenuse? Yes, that's right. It's the longest leg of a right triangle. And what is the Pythagorean theorem? Say it correctly. It's not a2 plus b2 equals c2. It's a squared plus b squared equals c squared. And how can the Pythagorean theorem be used to find the missing length of a right triangle? Well, you add the squares of the two shorter legs, and the sum's square root is always going to be the answer to the missing longest leg. Here is our first example of a real life situation. The workers at this house have to bring a ladder to paint the outside of the windowsill. They can't put the ladder on the grass, and they can't put the ladder on the window. They must find a ladder that's exactly long enough to go from the cement to the window ledge. So here's the information you're going to need. First, the height. It's 8 meters to the ledge. And then, how far is it from the cement to the house? Well, that's going to be 6 meters. Once you have these two pieces of information, it gives you a greater understanding of how the Pythagorean theorem works. Because when you look at the 8 and the 6, they should look like the two legs of a right triangle, as in they form a right angle together. Then, if you took those two legs and you found the squares of 8 and 6, the sum of those squares would then allow you to work on finding the missing leg, in this case, which would be the ladder. Now, I'm not going to give away how it works exactly, but if you take a look at it right here, if you can think of what's the square of 8 and what's the square of 6, I know Willens has already got this, and you add them together, then you find the square root of that number, and the square root of that number is going to be the length that you're going to need for the ladder. In this case, it's 10. Okay, now, this is great, but you're going to need to use the formula in order to do it properly. So get ready to take a little bit of notes, or at least take a screenshot. Make sure that you're prepared to be able to write stuff down. We're going to do a few examples, starting with the one you just saw. So in the one you just saw, we used what's called the Pythagorean theorem. The Pythagorean theorem states that a squared plus b squared equals c squared. So we put together the parts right here. A was 6, b was 8, 6 squared plus 8 squared. That's 36 plus 64, which is 100. Remember, you could always pause or go back if you have to. Then we just need the square root of 100 in order to find the missing leg. If you look at your square roots list, 100 is a perfect square, and it does have a perfect square root, it's 10. So now looking at a second example. Here, the legs of the right triangle are given to you, 9 centimeters and 12 centimeters. You know these are the legs and not the hypotenuse because they are directly connected to the right angle. The letter C is there to indicate where the hypotenuse would be if you did know the length. It doesn't have to be a C, but for the basis of the formula, usually C is what's used. So let's see it in action. First, you take a squared plus b squared equals c squared. A was 9, b was 12, and what you're going to do is you're going to square those two numbers, 81 and 144, add them together is 225, and then if 225 is the square of c, all you need to do is find the square root of c. Square root of 225, 15. Try it one more time. Here we're given two legs again. You know they're the legs because they're connected to the right angle. 8 might be A and 15 might be B. That's the way they're labeled here, but remember, because we're going to wind up adding them, it doesn't matter which is A and which is B because of the commutative property. Now I know Dozy knew that one. C, on the other hand, is something we're going to have to figure out. In order to do that, we're going to take the square of A and the square of B and get it to equal the square of C. In this case, 8 squared plus 15 squared, that's 64 and 225. We add those together, we get 289. And then you look at your list and you say, is there a square root of 289? In this case, yes, there is. The square root of 289 is 17, which means that the missing leg or the hypotenuse must be 17. In this last question, something might be a little different. You might need some more information in order to solve this problem. So while you're looking at it, think about what the square of 5 is. Good, 25. And the square of 3, 9. Now if you add those together, what happens? Well, that's our cliffhanger. So make sure that you complete the handout that's connected to the assignment on Pupil Path. And if you have any questions, make sure that you send me those questions, and I will get back to you as soon as I can.